So for these problems, what we're going to do is, now some teachers teach you to do a sign chart. Is that what they call it?
Yeah, we do. It's like a sign test.
A sign test. So the way you would do that is you would graph this. So I'll show you this one right here. You would, first of all, set it equal to 0, like you always do, because that way that allows you to see, first of all, what the factors are. If you can factor it, it's always easier if you can factor it. By the way, one of the things I would do right away here is just get rid of the negative. So like divide everything by -1. Divide the entire equation by -1, just turns everything positive in this case.
Yeah.
And that just makes it a lot easier to see. So it's x plus 1 times x plus 1, right? Or x plus 1 squared, right?
Yeah.
So that graph, so what you would do is you would take the way that your teacher might want you to do it is to put at -1, so you can see that x equals -1, right? That's your only 0. You follow what I'm saying?
Yes.
Okay. When you plug in -1, then you want to find out what the sign is of values to the left and to the right of it. So if to the left of it would be like, let's say -2. And if I plug -2 into here, I get -2 plus 1, which is -1. And then another -2 plus 1, which is -1. -1 times -1 is
Positive.
a positive. So you just put a positive there. You don't actually have to find out what that equals. And then maybe do it for 0 as well, something to the right. 0 is always the easiest one to do. And that would give you, if you plug 0 in here, it would give you 1 times 1, which is what?
0. Oh, 1, sorry.
Yeah, it's 1, it's a positive, right? So it's going to be positive on both sides. Now, that's what your teachers might tell you to do, or might even insist that you do. I wouldn't do it that way.
Okay.
The way I would do this problem, because you've done it before, you know how to graph this. What is x plus 1 squared? What kind of equation is that?
Quadratic.
It's a quadratic, and it's shifted where?
X plus 1 to the left.
Yeah, it's shifted 1 to the left. So your normal graph, so your base, and is it going up, opening up or down?
Up.
It's opening up. So I would just do that. And then you can see, oh, look, it's positive on the right, and it's positive on the left, and it equals 0 at -1. So because it doesn't say the equal to portion there, we're going to have to write our answer out like this: from -infinity to -1, union from -1 to infinity. Teachers may or may not want you to write the U in the middle there. Make sense?
Yes.
Let me also use this opportunity to talk to you about multiplicity. Has your teacher explained to you multiplicity?
Kind of, but he didn't really go into it.
Okay, so multiplicity for zeros, multiplicity of zeros. If it's even multiplicity, then it bounces. It doesn't go through the x-axis. If it's an odd multiplicity, then it goes through.
Okay. Oh, yeah.
Right? So since this is, see how this is an even multiplicity? Because it's squared. That's why it didn't go through. That's why it bounced off. Okay, and that's another really good thing to know. I'm sure we'll do an example here in a minute relating to that. All right, this is a different kind of problem. So for this one, I'll write it over here. It says 2 over x minus 1 minus 1 over x plus 2 is less than or equal to 0. So for a problem like this, we're going to have to first combine it together into one big fraction.
Okay.
Right? You remember how to do that?
Yeah, you multiply.
Yeah, you're going to have to get common denominator. So what am I going to have to multiply this first term by? Can you tell?
No.
I'm going to just delete that. So this first term, I'm going to have to multiply by the denominator it doesn't have, which is x plus 2. But I'm going to have to do that on the bottom and on the top to preserve that fraction. Make sense?
Yes.
And what would I have to multiply the second term by? This one right here.
The other denominator?
X minus 1. X minus 1. Now be careful when you're doing this. Make sure you do it correctly. So you're going to get 2 times x plus 2 minus 1 times x minus 1 all over. Now we have the same denominator, common denominator, so we can just write them both underneath there. Now let's simplify this, the top up here. What's 2 times x?
2x.
2 times 2? Plus 4, right? And then what do I do with this negative 1 here? Do I have to do anything with this?
Do you get into the x minus 1?
Yep. So what is that going to equal?
Negative x plus 1.
Perfect. Good job. So now I'm adding like terms here. What is that top going to simplify to?
3x plus 5.
Careful. 2x minus x is what?
Oh, 5.
X plus 5. Good. On the top and on the bottom, it's x plus 2 and x minus 1. I'll even put parentheses around it so it's easy to tell that's a factor. All right. So what are my things I'm going to draw on my line?
Negative 5, negative 2, and 1.
Good. And not only that, but I'm going to put a dot where?
I don't know. Oh, wait, no.
Remember which one gives you your x-intercepts or your zeros? Is it the numerator or the denominator? Remember doing rational functions?
I think it's, numerator.
It's the numerator, that's right. The denominator doesn't really matter. 0 over anything is 0. You can't really divide by 0. So these denominators are really giving you asymptotes, right? These represent vertical asymptotes.
Yeah.
Remember doing that. So there's your 0 right there. And does it go through or does it bounce off of that? Just out of curiosity, do you know?
Yeah.
What does it do? Go through or bounce?
5.
Do you remember?
Bounces.
Let's go back and read the notes that I just gave you. The multiplicity of zeros.
So it goes.
If they're even, they bounce. If they're odd, they go through. So is this multiplicity even or odd right here?
Odd.
So it goes through, right?
Yeah.
So now let's plug in some values. What value should I plug in first? Let's test some different things out.
Negative 6.
Okay, so f of negative 6. What's the top sign going to be?
Negative 6 plus 5, negative, and then
Negative over
negative 6 plus 2, negative, and then negative.
Negative and a negative. And what's 3 negatives give you?
Negative, negative.
So this is a negative. How about to the right of negative 5? What am I going to put? Or do I even have to do that?
Do what?
Do you even have to check to the right of negative 5?
No.
What do you know has to happen? If this is negative, what does that have to be?
If it goes through, it has to be positive.
It's got to be positive. That's the reason why it's good to know the multiplicity tricks. You understand? So I know this has to be positive, unless I made a mistake somewhere. So you can test something. Let's plug in -4. What am I going to get? Positive
Okay, -4
over.
plus 5 is positive. -4 plus 2 is negative. And then -4 minus 1 is negative.
Which is
But
positive,
it's
right?
positive, so it's positive.
That worked out. How about in between here? What am I going to do? In between -2 and +1?
-2 and positive. To plug in?
Yeah, what should I plug in?
-1.
You could, but wouldn't 0 be a little easier?
Oh, yeah.
Always use 0 if you can.
Okay.
That's just going to give you what? Positive over.
And then negative, so.
Which is what?
Negative?
Actually, I'm going to put that underneath here because that makes a little more sense for me to put the negatives underneath, right? And how about to the right of 1?
We did 2. Positive, 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 so positive.
Now I'm going to teach you the multiplicity trick for vertical asymptotes. Multiplicity of Vasey's. If it's even, that means it approaches the same way, the same direction. If it's odd, it approaches in opposite directions.
Okay.
So that makes sense for what I just did. What's the multiplicity of this 0 right here?
Even, so it approaches the same.
No, not even. What's the multiplicity of this 0?
Odd.
There's just one of them. How about this one?
Odd.
So both of these, it's approaching from opposite directions. So see how this one is going up because it's positive, and this one's going down. Both ways it's going down here. This one is going up. So see how it's going opposite directions to that asymptote?
Yeah.
One's going down and one's going up. That's what the multiplicity helps you find. Okay, give me another problem. I'll just write it out. Okay. Sorry, did I go too quickly, or did you understand what I just showed you?
No, I got that, yeah.
Okay.
A new part, let me find it here. Okay, so in parentheses, x squared minus 9. And then another parenthesis, x minus 1. And then is greater than or equal to 0.
Okay. So notice that this can be factored further into what?
It'd be x plus 3x minus 3.
Perfect. Good. Difference of perfect squares. Good. Now let me show you the way I would prefer to do this. I don't need my number line, my sign analysis. I know I've got a -3, I've got a +3, and I've got a +1. And what's the multiplicity of all of them?
Odd.
It's odd. Multiplicity 1, multiplicity 1, multiplicity 1. So here are my points: -3, +1, and +3. Do you remember? This is a cubic with a positive leading coefficient. Do you remember the end behavior rules for these? Do you remember how the end behavior works? If you have a leading coefficient that's positive, that means that the right goes up.
Okay.
That's what that means. So I know this has to go up.
Yeah.
And I know it has to go through because the multiplicity is 1. Got it?
Yes.
And when it comes back, is it going to go through or bounce off on this 1?
It's going to go through.
It's going to go through. And then is it going to go through or bounce off on this?
It's going to
go through. And look how it's going down at the end, which is good because when it's cubic, meaning odd, it goes in the opposite direction. Here, let me write that below here, because the first thing you do is you look at the leading coefficient. And then the next thing you do is you look at the degree. If the degree is odd, then it goes opposite direction. Opposite direction to the left, which is down.
Yeah.
Does that make sense? So
Yeah.
this is going down to the left, and that checks out. So I didn't actually have to even plug in any values.
Yeah.
I didn't have to waste any time, and I could just very quickly and easily do that.
Mm-hmm.
Okay. Now
Mhm.
you could plug in values if you want. You could go through and do like the f of -4, and you could do the f of 0, and then f of 2, and then f of 4. But that's a lot more work, in my opinion,
Yeah.
than just looking at the graph and figuring it out. So let's try another one. Give me another example.
Okay. No parentheses, x cubed minus x squared, and then is less than 9x minus 9.
Okay, what's the first step?
To set it equal to 0.
Perfect. So I'm gonna what with the 9x?
You're gonna subtract it.
Good. And how about the 9?
You're gonna also subtract it, yeah.
Nope, careful.
Oh, add it because it's
Good. I tricked you.
Mhm.
All right, now I'm gonna factor by grouping. Can you see how that can happen here?
Yes.
When I take an x squared out of here, I get x minus 1. And when I take a -9 out of here, I get x minus 1.
Mm-hmm.
Do you see how I did that?
Yeah.
And now this can come out of both of these terms. If I take an x minus 1 out of that first term, what am I going to be left with? If I take an x minus 1 out of this term, what will I be left with?
X squared.
Mm-hmm. And if I take an x minus 1 out of this term, what will I be left with?
-9.
Minus 9. Good. And now how does the x squared minus 9 factor?
It'd be the x plus 3x minus 3.
Mm-hmm. Perfect. So what are my zeros?
3 and -3 and 1.
And all of them have multiplicity what?
Odd.
Yep, odd multiplicity, so they all go through, right? So
Yes.
watch how easy this is. Watch how easy this is.
Mm-hmm.
Here's -3, here's 1, here's 3. It's an odd, leading coefficient is positive, and it's an odd degree. That means it goes up to the right, and this means it goes down to the left. And all of them go through. So
Yep.
it's just like the other one. Through, through, through.
Mhm.
So, oh, by the way, I didn't answer the question last time, did I? I just drew it. Now I have to answer the question.
yeah.
So where is it greater than or equal to 0? It's greater than equal to 0 here to here and here to there. So from -3 to 1, whoops, I should be including them, right? Because it says greater than or equal to. So from -3 to 1, union from 3 to infinity. That was that one. Got it?
Yes.
How about this one? What's this going to be? Where is it less than 0?
-infinity to 3.
Good.
And then 1 to 3. Or -3.
-infinity to -3, I think is what you meant to say.
Yeah.
Or maybe you said it. And then is it included or not?
Not.
Not. Very good. Union, what else?
1 to 3.
And is it included, either of those?
No.
Perfect. You got this. Good job. So do you see how easy it was to do by doing it like that instead of having to plug in values?
Yeah.
Does that make sense? How that can work, and that's pretty easy.
Yeah.
Sometimes when you have rational functions like the first few that you did, it's easier just to do the sign analysis. But definitely with the polynomials, it's much easier just to do this graphical analysis, the end behavior
Yeah.
tricks and that kind of thing. I think we have time for one or two more. You have another one?
Yeah.
What? Give me another rational function one. Those are trickier.
Okay. Okay, x cubed plus 4x squared is greater than x plus 4.
Okay, that's not a rational function, but that's okay.
Yeah.
This is just a, yeah, you keep looking for one. You'll find one. There's a bunch that you've been doing, like particularly ones with holes, RDs. So I'm going to subtract 4 from both sides. Oh, this is just like the last one. Factor by grouping. X squared comes out and x plus 4 stays in. What comes out over here?
Sorry, was it x plus 4?
I want this to be x plus 4 so I can factor it out. So what would I have to take out?
The negative.
A -1. That's right, or just a negative. So when I factor an x plus 4 out, I'm left with an x squared minus 1, which is nice because what is x squared minus 1?
X plus 1, x minus 1.
Yep. So this is just like the other one, right? Leading coefficient's positive again. We've got -4, -1, and 1. So here's -4, here's -1, there's 1. You know it's going up to the right, it's going down to the left, it goes through all these places. There we go. And we want it to be greater than. So it's from here to here, not including, and here to there, not including. So my answer is -4 to -1, union 1 to infinity. Follow?
Yes.
All right, I know I did that fast, but you're really getting this. All right, come on, find one. Find a rational function. Find one where you have a denominator and numerator.
Okay, I got one.
Go ahead.
Okay, so numerator is x squared plus 2x minus 15. And
minus 15, you said?
Yeah, minus 15.
Okay.
And then denominator is x squared plus 7x.
Okay, greater than or less than 0?
Sorry, 0.
Greater than, equal to, or no?
No.
No? Okay. So we're going to factor the top and the bottom, if possible. Can you see how this factors?
5
and 3, which one's positive and which one's negative?
3 and 5.
Which one's positive and which one's negative?
So
the 5 would be positive and the 3 would be negative, because that way it'll give you a positive 2 in the middle. 5x minus 3x is 2x. Got it? What factors out of the bottom?
7x, it would be.
How about an x?
X.
It's just x that factors out. And what are you left with?
X plus 7.
Perfect. So what are my zeros?
-7, -5, and 3.
It's actually only -5 and 3 are my zeros. What are my VASIs?
-7.
-7, and you're missing one. What's this one give you? People always forget this.
-x.
Set this equal to 0. It's just 0. No, not at -x. It's 0. Right?
Yeah.
You understand that?
Yeah.
We're setting all those equal to 0, so it's just 0. So here's my graph. I've got -7, -5, 0, and 3. And my zeros are here and here, and they're both multiplicity what?
Odd.
They're both odd, so they go through, right? These are my asymptotes, and they're both multiplicity what?
Odd.
Odd, so they go through. So let's plug in some values here. Now, again, what I would do for this, honestly, is I would just graph it. Because to me, this isn't hard to graph. You know there's going to be a horizontal asymptote at 1.
Yeah.
Right?
Yeah.
And you know that it's got to approach, so you can see what has to happen. It has to go like this, right?
Yeah.
This has to approach this way because it's odd multiplicity, and it has to go through, I mean, it can go through that asymptote, but it has to go down there. And this one has to be up here. There's no other place that could go, because if it was down here, it would touch the x-axis again.
Yeah.
And it has to go in the opposite direction of that.
Mm-hmm.
Do you see what I'm saying? So
Yeah.
I actually didn't even have to plug anything in, because I had some zeros already, and I'm done. I'm done, and I know I did it right. So what's my answer going to be? My answer is going to be, where is it greater than 0? It's greater than 0 all the way over here, because all of that is above the line.
Yep.
All the way from here to there,
and
all the way from there to there.
Yeah.
So my answer is from -infinity to -7, not including, from -5 to 0, not including either, because it's not even greater than or equal to, and then from 3 to infinity. Done. Now you could have done the other trick. You could have done the thing where you plug in f of -8, f of -6, f of -2, let's say, f of 1, let's say, and f of 4. But look at all the work you'd have to do.
Yeah.
It was much easier to just go ahead and graph it, because you just finished that whole unit, graphing rational functions. Graph it and utilize the fact that you understand how multiplicity works now to make sure that you're graphing it correctly.
Yeah.
Not that this is hard to do. Like I said, -8, it would be a negative times a negative over negative times a negative. So that's positive, which we know it is.
Yeah.
-6, it would be negative over a negative over a negative over a positive. So that's negative, which we know it's a negative as well. -2, again, I'm just doing this for your benefit in case you want to do it the other way. -2, I'm plugging -2 into here, 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 and here, and I'm finding out what the values are, positive or negative. So that's a positive, that's a negative, and a negative, and a positive, which is what?
Positive.
A positive, which I knew it was
Yeah.
because of my graphical analysis before, right? But again, we're just checking. A +1 is going to be a positive and a negative, and a positive and a positive, which equals a negative. And then 4 is going to be a positive and a positive and a positive and a positive, which is positive, which we also knew. Okay. Good.
Yeah.
Awesome. Well, hopefully that helped you out.
Yeah, it did.
And that will be on YouTube if you want to watch that. It's live stream ending now.